11. The elastic potential energy of a strained body is A. Stress times strain. B. Stress divided by strain. C. Stress times strain divided by volume. D. 1 divided by 2 times stress times strain times volume. Correct answer: D. 1 divided by 2 times stress times strain times volume. Explanation: elastic potential energy density equals open parenthesis 1 divided by 2 close parenthesis times stress times strain. Therefore, total elastic potential energy equals open parentheses 1 divided by 2 close parentheses times stress times strain times volume. 12. Which of the following statements are true in respect of nuclear binding energy? I. The mass energy of a nucleus is larger than the total mass energy of its individual protons and neutrons. T. If a nucleus could be separated into its nucleons, an energy equal to the binding energy would have to be transferred to the particles during the separating process. The binding energy is a measure of how well the nucleons in a nucleus are held together. In nuclear fission is somehow related to acquiring higher binding energy. A statements I, K, and 3 are true. B statements T, 3, and EV are true. C statements T and 3 are true. D. All the 4 statements are true. Correct answer: B statements T, 3, and IV are true. Explanation: I. False. The mass of nucleus is less than the sum of individual nucleons. 2. True. Energy must be supplied to overcome binding energy. 2. True. Binding energy measures nuclear stability. IV. False. Fission releases energy, doesn't require higher binding energy acquisition. 13. A satellite of mass m rotates round the Earth in a circular orbit of radius r. If the angular momentum of the satellite is J, then its kinetic energy K and the total energy E of the satellite R. A. K equals J squared divided by m times R squared. E equals negative J squared divided by 2 times m times R squared. B. K equals J squared divided by 2 times m times R squared. E equals negative J squared divided by 2 times m times R squared. CK equals J squared divided by 2 times m times R squared. E equals negative J squared divided by m times R squared. DK equals J squared divided by 2 times m times R squared. E equals negative J squared divided by m times R squared. Correct answer: BK equals J squared divided by 2 times m times R squared. E equals negative J squared divided by 2 times m times R squared. Explanation: B. Angular momentum J equals m times v times R. Kinetic energy K equals open parentheses 1 divided by 2 close parentheses times m times v squared equals open parentheses 1 divided by 2 close parentheses times m times open parentheses J divided by m times R close parentheses squared equals J squared. Divided by open parentheses 2 times m times R squared close parentheses. For circular orbit, total energy E equals negative K equals negative J squared. Divided by open parentheses 2 times m times R squared close parentheses. 14. What force F is required to start moving this 10 kg block shown in the figure, if it acts at an angle of 60 degrees as shown? A. 2272 N. B. 2497 N. C. 2556 N. D. 2732 N. Correct answer: none of the option is correct. Explanation: normal force N equals m times g minus f times sine 60 degrees. Friction force F equals mu sub s times n equals 0.6 times, open parentheses, m times g minus f times sine 60 degrees, close parentheses. For motion, F times cosine 60 degrees equals F. F times cosine 60 degrees equals 0.6 times open parentheses m times g minus f times sine 60 degrees, close parentheses. F times open parentheses 0.5% close parentheses equals 0.6 times open parentheses. 98 minus 0.866 times F close parentheses. F times open parentheses 0.5 plus 0.5. 2 close parentheses equals 58.8. F approximately equals 24.97 N. 15. Light of wavelength 6,000 angstrom is incident on a thin glass plate of Re 1.5 such that the angle of refraction into the plate is 60 degrees. Calculate the smallest thickness of the plate, which will make dark fringe by reflected beam interference. A. 1.5 times 10 raised to power negative 7 m. B. 2 times 10 raised to power negative 7 meters. C. 3.5 times 10 raised to power negative 7 m. D. 4 times 10 raised to power negative 7 m. Correct answer: D. 4 times 10 raised to power negative 7 m. Explanation: for dark fringe in reflected interference, 2 times mu times t times cosine r equals m times lambda for minimum thickness. 2 times 1.5 times t times cosine 60 degrees equals 1 times 6,000 times 10 raised to power negative 10. 2 times 1.5 times t times 0.5 equals 6,000 times 10 raised to power negative 10. 1.5 times t equals 6,000 times 10 raised to power negative 10. T equals 4 times 10 raised to power negative 7 m. 16. Consider a circuit where a cell of EMF E sub 0 and internal resistance R is connected across the terminal A and B as shown in figure. The value of R for which the power generated in the circuit is maximum is given by A. R equals R. B. R equals 2 times R. C. R equals 3 times R. D. R equals R divided by 2. Correct answer: C. R equals 3 times R. Explanation: 3 resistors R are in series. Total external resistance equals 3 times R. For maximum power transfer, external resistance equals internal resistance. 3 times R equals R, so R equals R divided by 3. 17. The equivalent capacitance of a combination of connected capacitors shown in the figure between the points P and N is A. 3C, B. 2C divided by 3, C. 4C divided by 5, D. 5C divided by 2. Correct answer: B. 2C divided by 3. Explanation: this appears to be a specific circuit configuration. Without the exact diagram, it's difficult to determine. But based on the answer, it likely involves a combination of series and parallel capacitors that results in 5C divided by 2. 18. In a single-slit diffraction experiment, the slit is illuminated by light of two wavelengths, lambda sub 1 and lambda sub 2. It is observed that the second-order diffraction minimum for lambda sub 1 coincides with the third diffraction minimum for lambda sub 2. Then, bar a lambda sub 1 divided by lambda sub 2 equals 2 divided by 3. B lambda sub 1 divided by lambda sub 2 equals 5 divided by 7. C lambda sub 1 divided by lambda sub 2 equals 3 divided by 2. D lambda sub 1 divided by lambda sub 2 equals 7 divided by 5. Correct answer. C lambda sub 1 divided by lambda sub 2 equals 3 divided by 2. Explanation for single-slit diffraction: minima occur at a time sine theta equals n times lambda. For second minimum of lambda sub 1, a time sine theta equals 2 times lambda sub 1. For third minimum of lambda sub 2, a time sine theta equals 3 times lambda sub 2. Since they coincide, 2 times lambda sub 1 equals 3 times lambda sub 2. Therefore, lambda sub 1 divided by lambda sub 2 equals 3 divided by 2. 19. The acceleration time graph of a particle moving in a straight line is shown in the figure. If the initial velocity of the particle is 0, then the velocity time graph of the particle will be A. Triangular velocity graph, B. Curved velocity graph with plateau, C. Step function, D. Linear with discontinuity. Correct answer: D. Linear with discontinuity. Explanation: since velocity is the integral of acceleration, a triangular acceleration graph gives a parabolic velocity graph. The velocity increases parabolically until t divided by 2, then decreases parabolically back. 20. The position vector of a particle of mass m moving with a constant velocity bold y is given by bold r equals x of t times bold I hat plus b times bold j hat, where b is a constant. At an instant, bold r makes an angle theta with the x-axis as shown in the figure. The variation of the angular momentum of the particle about the origin with theta will be a constant horizontal line, B. Sinusoidal, C. Decreasing curve, D. Increasing linear. Correct answer: a constant horizontal line. Explanation: angular momentum bold L equals bold R cross M times bold V. Since bold V is constant and B is constant, the magnitude of angular momentum equals M times V times B, which is constant regardless of theta. If you found this video helpful, please like and share it. For any queries, leave a comment below. Subscribe to stay updated.